Azure, your vision, your cloud. So this is how you turn your ideas into a new app, reimagine an existing system, or create a hybrid or a cloud application with confidence. So no matter where no matter the platform or where you are on the journey to the cloud, Azure is the way to go. So what is the cloud? The cloud isn't just about the bits and bytes. It's about a mindset. It's a way of transforming your business. It is the practice of storing regular used computer data and on multiple servers that is accessible through the internet. Okay, so there are numerous terms out there when it comes to the cloud. So it's known as the cloud, cloud computing, cloud services, etc. Microsoft thinks of the cloud as simple an approach to computing that enables applications to be delivered at the scale for a variety of workloads and client devices. Cloud can help deliver IT as a standardized service, so freeing you up to focus on your business. Okay, so this is what Azure provides. It gives you environments for your apps, machines, rack spaces, switches, connecting devices, automated deployments, redundancy, load balancing, flexibility in the cloud. This is what Azure is currently. There is a lot to talk about in the industry when it comes to platform as a service, infrastructure as a service, and also software as a service. Microsoft first announced Azure, which is the focus that has been for delivering platform as a service offering where you can build applications, where the platform abstracts you from the complexities for building and running applications. We fundamentally believe that the future path forward for development is by providing a platform. There's a lot of confusion in the industry when it comes to the cloud. It's important that you understand both what is happening in the industry and how we think that how we think about cloud. This is the most commonly used taxonomy for differentiating between types of cloud services. The industry has defined 3 categories of these services, as you can see on the screen: infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service, it is a set of infrastructure level capabilities such as an operating system, network connectivity, etc. These are delivered as a consumption base that can be used to host applications. Next, you get platform as a service. These are higher level sets of functionality that are delivered as consumable services for developers who are building applications. Platform as a service is about abstract developers from the underlying infrastructure to enable applications to quickly be composed. Next is software as a service. So what is this? These are applications that are delivered using a service delivery model where organizations can simply consume and use the application. Typically, an organization would pay for the use of the application, or the application could be monetized through to add revenue to your organization. It is important to note that these 3 types of services may exist independently of one another or combined with one another. Software as a service offering needn't be developed upon platform as a service offering, although solutions built on platform as a service offerings are often delivered as software as a service. Platform as a service offering also needn't expose infrastructure as a service, and there's more to platform as a service than just running platform on an infrastructure as a service. Okay, so next, the types of storage accounts. This is what I'm going to cover. So looking at the storage accounts, general purpose storage accounts, there are two types of general purpose storage accounts. One being the standard, the other being premium. So standard is the most widely used storage account, which can be used for all types of data. Standard storage accounts use magnetic media to store data, whereas premium storage provides high performance storage for page blobs, which are primarily used for VHD files. Premium storage accounts use SSDs to store data. Microsoft recommends using premium storage for all VMs spun up in Azure. Blob storage accounts. The blob storage account is a specialized storage account used to store block blobs and append blobs. You can store page blobs in these accounts, therefore you can't store VHD files. The accounts allow you to set an access tier or even a hot or cool tier, right? The tier can be changed at any point in time. The hot access tier is used for files that are accessed frequently. You pay a higher cost for storage, but the cost for accessing the blob is much lower. For blobs stored in the cool access tiers, you pay a higher cost for accessing the blobs, but the cost of the storage is much, much lower. The design point in the cloud is the availability of storage. There are 3 replicas of data, and we implement a consistency, or rather Microsoft implements a consistency. In the future, there will be some transaction support, and this is why we use guaranteed consistency. There are 4 types of storage, naming a few of them, starting with tables, queues, blobs, and files. So tables are for your key value storage. Queues, a simple query mechanism. Blobs are your binary file storage in the cloud. And files, which are managed file shares for cloud or on-premise deployments. So blobs, tables, queues, and files in the cloud are close to your computation, right? Authenticated access and triple replication to help keep your data safe. So this is how Microsoft So as mentioned, these are the 4 storage types: blob storage, files, tables, and queues. Looking at this page, as mentioned, blobs are your file system in the cloud. Tables are your massively scalable structured storage. Queues, reliable storages for delivering messages across. And then files, which are used for on-premise and cloud deployments. These can be accessed via the REST APIs and the client libraries. Having a look at the Azure data storage concepts. So you have account, and then you have containers, tables, and queues. Looking at these, so how storage works is that these are actually accessed via URL links. So if you notice the container on the top, it is accessed via the blob, whereas the table is accessed via the table name, and then the queue is accessed via the queue name. So these are the URLs used when creating or after you've created a storage account for a client or a user. Okay, blob storage. Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data, such as your text or binary data. Blob storage is ideal for serving images or documents directly to the browser, storing files for distributed access, streaming videos and audio, storing data for a backup or a restore, disaster recovery, and even archiving, storing data for analysis by an on-premise or Azure hosted service. So these are what blob storages are. So these objects or objects in the blob storage can be accessed from anywhere in the world via an HTTP or an HTTPS URL. Users or client applications can access blobs via URLs, such as Azure Storage REST APIs, Azure PowerShell, or Azure CLIs, which is your command line interface. There are two types of blobs. One being the block blob, the other being the page blob. So these are actually so the block blob is just targeted to streaming workloads, whereas page blobs are targeted at random read or write workloads. And as you can see, block blob gives you a size limit of approximately 200 gigs per blob, whereas your page blob gives you about a terabyte per blob. You can create or modify a block blob by uploading a set of blocks and committing them by the actual block IDs. If you are uploading a blob that is more than say approximately 64 megabytes in size, you can also upload it in its entirety with a single a put blob operation. When you upload a block to Azure by using the put blob operation, it is associated with a specific block blob, but it does not become a part of a blob until you call the operation. So in this case, put block list, for instance, that is one of the operations. It's also known as, which also includes a block or block ID. The block remains in an uncommitted state until it is specifically committed. Writing to a blob is thus always a two-step process. So each blob can either be a maximum 4 megabytes in size. The maximum size for the block blob is approximately 200 gigs, as mentioned. So page blobs are actually a collection of pages. Page is a range of data that is identified by its offset from the start of the blob. To create a page blob, you actually initialize the page blob by calling a put blob operation and specifying its maximum size limitations. Add content or to update a page blob. You call a put page operation to modify the page or a range of pages by specifying an offset or and a range. So all pages must align to approximately about 512 bit page boundary. Unlike write block blobs, writes to a page blob happens in place and are immediately committed to the blob. The maximum size for the page blob is 1 terabyte. So moving over to shared access signatures. So shared access signatures provide access rights to containers and blobs at a more granular level than by simply setting a container's permission. So for instance, grant user access to a specific blob or to any blob within a specified container for a specific period of time. So giving someone access to just that container or that blob just for instance, 24 hours. So this shared access signature gives you or gives a user rights to have access to that container just for a specific period of time, which is good if you have high. Well, it's actually to reduce people from accessing your data at any given time. So giving them a specific range where you can adjust or amend the data within that specific time. And also specify what operations a user may perform on a blob that's accessible via a shared access signature. So there are two approaches to this, right? You get the ad hoc approach and you get the policy-based. So ad hoc it's a use for a very short-dated single use case scenario, whereas the policy-based used for a long-dated revocable permission set. So just one note on that. Always endeavor to use the least permission set possible, because you don't want people accessing the data out of the specific time period that you've given them, because you never know where data might go corrupt. So this is actually a good way of giving people access just for that period in time. As mentioned, ad hoc shared access signatures. So these include all permissions and expiry in the signed URL. You can only revoke by deleting the blob or waiting for expiry. As you can see here, from there to there is the date and the time for when you've assigned specific. This is when you assign a specific time for a user to access data in Azure or using the URL, and this would be the starting time, whereas this would be the ending time where the user has to access the data or make changes to the data. So as mentioned earlier, storage is accessed via URLs. So this is how a specific URL would actually look like when you're creating a storage and assigning permissions, roles, so forth to users. Policy-based. So these policy-based signatures or shared access signatures. This is one part of shared access signatures. So these contain a level. Well, these are actually a level policy where a user wants a longer dated permission with the ability to revoke that access or the permission to that storage account. This includes all permissions and expiry, which is assigned in the URL itself. Yeah. So this can only be revoked by deleting the blob or waiting for the expiry on that blob. Moving over to tables. Azure Table Storage stores large amounts of structured data. The service is a NoSQL data store which accepts authenticated calls from inside or outside the Azure cloud. Azure Tables are ideal for storing structured non-relational data. Common uses of the table storage would be storing terabytes of unstructured data capable of serving web-scale applications, storing data sets that don't require complex joins, foreign keys, or stored procedures, and can be denormalized for fast access. Another point is quick querying data using a clustered index. The table storage would be considered for that. Also, accessing data using an OData protocol and a link queries. These are used with the WCF data services or .NET libraries. You can use table storage to store and query huge amounts of unstructured and non-relational data. So just keep that in mind, that if you have unstructured non-relational data, tables is the way to go forward. And your tables will scale as the demand for data increases on this. Looking at queues in storage. The Azure Queue service is used to store and retrieve messages. So queue messages can be up to approximately 64 kilobytes in size, and the queue can contain millions of messages. Queues are generally used to store lists or list of messages to be processed. For example, say you want your customer to be able to upload pictures. You want to create thumbnails for each picture. You can have your customer wait for you to create the thumbnail while uploading the pictures. An alternative would be for you to use a queue. When the customer finishes his upload, or write a message to the queue, then have an Azure function retrieve the messages from the queue and create a thumbnail or multiple thumbnails, each of which is each of the parts of this processing can be scaled separately, giving you more control when tuning in for usage asynchronously. This is how a queued storage concept looks like. So you'll have your account, which is your AdventureWorks, your table, which is probably in a retail industry ordering process or your procurement, and then the messages, which is what you want to retrieve at the end of the day. So, for instance, this case, customer ID, order ID, etc. So this is what queue storage concepts are used are used for. Moving over to Azure Storage Explorer. So this is used with each and every storage that Azure provides. So may it be blobs, may it be files, it may be tables or queues. Everything is actually done or managed through this. This is a free tool that is available for download from the Microsoft Azure website. Give it a shot. I've played around with this. It's quite easy, simple to navigate, and it's also cross-platform compatible, which means this will work on Windows devices as well as Mac devices. So this is actually used to easily manage content of your storage account with Azure Storage Explorer. You can upload, download, and manage blobs, files, queues, tables directly from this. So it gives you easy access to manage your virtual machine disks, your storage accounts, etc. So one of the other things I wanted to cover in this one-on-one session is Azure file share. So we know that in an on-premise environment, we always have attached network drives, right? So this is one way of using Azure as a network drive. So apart from OneDrive, Azure file share is another way of having access to all your files and folders and data immediately. And this actually appears as a network, an attached network drive on your machine. So if you have a look at the screenshot on the screen, this is the My Azure file account storage. So this is a storage account that had been created already. And what we're going to do is I'm going to run you through the slides where it's going to help you, or it's going to guide you through the process of creating a file share in Azure. So once your storage account has been created, go into your storage account. The dashboard or the blade will appear where you'll see your blobs, files, tables, and queues. So whatever I've discussed earlier in this presentation, everything appears here. So you can access your blobs, your tables, your queues, and also your files directly from here. So what we're going to do is, because I want to show you what a file share is like, we're going to go ahead and we would actually click the files tab or the box. So once you click on the file service box, it brings you to another page where you would actually add a file share, right? So once you click on file share, it takes you to the next blade, which actually asks you to insert the name of the file share that you want to create in Azure, and you can even assign a quota to this file share. For instance, 500 gigs or 5 terabytes, for instance. Everything can be done directly through this blade. So once you've actually assigned, once you've created your file share name and you've assigned a quota, it'll bring you to the next blade where you would actually see the assigned file shares that you have created. So having a look here, My Azure file share or My First Azure file share. So we've created 2 of these. These are just for testing purposes, and as mentioned, I've assigned approximately 5 terabytes worth, which is the quota on each file share. Thereafter, what we would do is go into those file shares that we've created, and what we can do is we can upload data to this file share by clicking the upload button. bringing us to the next blade. So after uploading your documents or files to this file share or the storage account, what happens is it appears as if it was a normal a cloud storage space where you can see all your files and folders that you've uploaded into this storage space. So this is how it will appear. It appears the same as it would on an on-premise notebook or a server, for instance. So as mentioned, this file share can be mapped as a network drive, and these snippets actually guide you through the process on how you go about adding Azure file share or a storage account as a network drive. So as you would on a normal PC, you would go to this PC or my computer, click on Map Network Drive. This will actually map the network drive onto your machine. But as mentioned earlier, storage or blobs, queues, all storage within Azure is accessed via a URL. So what will happen here is you would actually go into your storage account or your file share, and you would actually copy the URL that has been assigned to that storage that you've created. So if you have a look at the blue snippet where with the red highlighted box, it gives you the my Azure file share.file.core.windows and then / my Azure files. So that's what the file share, or that was the file share that was created, and we're going to use the exact same thing to access the data or establish a connection from an on-premise machine to Azure directly. Having a look at the third snippet there, say of mapping a network drive. So from the second snippet, we're going to copy that into the box where it asks us for the folder path. So what that does is it links your on-premise directly to Azure using the URL that was created for the storage account. It's exactly the same as attaching a normal on-premise network drive. Here it is again, so mapping a network drive and how you go about accessing that storage account in Azure. So as you would do on-premise is you would probably have the name of the storage account. In this case, it would be my Azure file share account. But there's one thing to take note here is that before trying to access the storage account or trying to link your on-premise to Azure, you would actually use Azure / and then the name of the storage account that was created, or the file share name that was created, and not to forget the password that you've used. So as you can see in the third snippet, it actually appears as a network storage device. And yes, that's how you go about adding a network storage or file share in Azure. Okay, so looking at replications when it comes to storage, there are 4 different replication methods. They used to only be, I think, 2 or 3. Microsoft has released, or now 1 or 2. Well, one of them is available as, I think, as of a couple of months ago, where Microsoft has given users general access to it. So starting with the first one, local redundant storage. This is the simplest low-cost replication strategy that Azure Storage offers. Zone redundant storage, known as ZRS. This is a simple option for high availability and durability. ZRS fits between your LRS and GRS, right? So your local redundant storage and your global or geo-redundant storage in terms of durability and price. So the zone redundant storage stores 3 replicas of your data across 2 to 3 facilities. It is designed to keep all 3 replicas within the same region, but may span across approximately 2 regions. But ZRS currently only supports block blobs. So just to keep that in mind, it only supports block blobs. So zone redundant storage allows customers to store blobs at a higher durability than a single facility can provide with the local redundant storage. Geo-redundant storage. It's a cross-regional replication to protect against region-wide unavailability. So for instance, your data is sitting in North Europe, for instance. If something happens to that data center, although you have 3 copies within that data center, because you've enabled geo-redundant storage, it will replicate the data approximately 100 miles away. So it will replicate it from North Europe to approximately West Europe. So what that does is you have your 3 copies sitting in one data center, and then you have another 3 copies sitting in a different secondary data center, which is approximately 100 miles away. And moving over to the next one, which is read access geo-redundant storage. This is also cross-regional replication with the read access to the replica. This is the recommendation option for production services, which is relying on Azure storage. For a GRS or geo-redundant storage account, you have the ability to leverage higher availability by reading the storage account's data in the secondary region. Just having a look at the geo replication. So as mentioned, you would have East Asia, and then you have Southeast Asia. So what Microsoft does is it replicates your data from the current data center to a secondary data center. So in this case, either from North Europe to West Europe or from West Europe to North Europe. Right. So so these are some of the partner resources that I've attached to the presentation. I will be sharing this deck with everyone, so you can have a look at some of the sites you can visit for more information on this. I'm going to hand over to my colleague Glenn, who is going to take over the networking side of things.
Okay, thanks Parveen, and hi everyone. As Parveen mentioned, that my name is Glenn. I just want to ensure that everything is just fine, especially switching the slides. Switch. Okay, so basically I'll be taking you through to the network side of things in Microsoft Azure. So I just want to ensure that I can switch my slides. Let me ensure that. Okay. Just a quick test. Okay, 100%. I'm just going to go back from where the slides starts. Okay, so I'll be taking you through the virtual networks, VNet peering, so virtual network peering, the VPN connection, connectivity options, and the DDoS, so double denial of service protection we have in Microsoft Azure. So as we know that the core fundamental part of us having Azure also involves networking. So basically, what we are doing in Microsoft Azure, we are trying to map exactly what you have on-premise. So basically, normally in your on-premise network, you have your switches, your routers, and your subnets and your address spaces set up. Or some of the customers, they normally have some front end whereby they put their websites one aside, they put their databases aside, they put their file servers aside. So now, with Azure Virtual Network, so we are trying to achieve the same concept, which is software-defined networking. So the normal traditional networking you normally do on-premise, now it is software-defined. So now we have a complete control and network isolation. So the subnets which you create inside the virtual network, they give us the segmentation to say, only my web servers can belong on this subnet, and only my database servers can belong to this subnet, as shown on the picture on the right-hand side. So basically, you can see that the first subnet, which is the front end, you can define it as where you put your front-facing services, your websites, maybe your public DNS, and at the back end, you can put the second subnet, which is where now your application servers and your database servers reside. So now, also we have a support for static IP addresses. So basically, you wouldn't want your front-facing services to always have a changing IP address. So Microsoft Azure has support for static IP addressing. And also, having in mind that we have now segmented application and services, we have support also for load balancing. So basically, if you have a web farm which is front-facing to your customers, you can put there a load balancer. So in that picture on the right-hand side, we are balancing the load amongst our back-end database servers and our application servers. So putting that in mind, you have also an option to use your on-premise DNS to do name resolution, or you can use the one Microsoft Azure provides you. So you can also extend trust. So basically, you can also invite other people to be part of your network. So now, to connect two VNets, so let's say you have virtual networks, they have different subnets, but now you want to connect them together. So we have the first option, which is virtual net peering, VNet peering. So basically, if you have the first VNet with its own separate subnet, you can peer it to the second VNet, which also has its own separate resources. So the thing is, here they have to be on the same region, inside the same data center. Or if they are in different regions, maybe you are creating a DR, disaster recovery scenario, where you don't want to put all your resources on one region, then you can go to the option for site-to-site VPN, linking the two VNets together. So now, obviously, the connection is secure with IPsec, IKE, we support V1 and V2, and for site-to-site channeling, then we can establish that connection. As you can see on that top picture there, we have the VPN gateway on the left and the VPN gateway on the right. So this allows your network to expand in different regions. So moving right along, now we have the connectivity options and offerings we have in Azure. So the first one, which is internet connectivity, is where now your customers, they are interacting with your applications and services in Azure over the internet connection. So basically, your consumers can access those services over any public IP address. So it can also allow them to connect to your services anywhere from any device. But now, going down to point to site, this is where now you on-premise, you have your developers who are developing maybe a line of business application. So now your developers can utilize a point to site, which allows small scale deployments and can connect your developers anywhere. So basically this is for proof of concept. It's not mainly to connect your whole enterprise into the cloud. So it is just giving them access to have control on the resources in Azure for testing purposes. And now when you have your SMB and your enterprises, that's where now we use a site-to-site VPN connectivity. So basically you will have your VPN gateways. Normally it will be your remote server access services or your Cisco routers which have VPN capability. So you can connect your entire organization or your entire data center directly to Azure, which makes Azure a second site to your on-premise network. And finally, there are some use cases where you need to run mission critical workloads. So you run your big data, you run backups, you run disaster recovery, and you need high throughput and low latency connection. Then you can opt for the express route. Currently in South Africa, we don't have it yet, but as the regions are being deployed in Joburg and Cape Town, there will be a service provider which will offer us the option to connect express route directly to Azure. So take it as if you are having a direct link to the Azure fabric. So that means you don't have to go through the internet, which even makes the connection to be more secure. So now I'm going to also observe a bit in detail about the site-to-site virtual network. So here it allows you to extend your on-premise network to the cloud. So basically this configuration, it allows you or your network administrator to establish a connection which is an IPsec channel, as I've mentioned before, between your company on-premise and the network you have defined, which is your VNet you have defined in Microsoft Azure. So basically, you first need to make sure that you identify the domain naming service or your name resolution so that it can automatically give the on-premise machines of Hyper-V machines or your vSphere or your physical servers to be able to resolve the services of virtual machines which are running in the cloud. So now what also you do is you have to define on your local networks which subnets will you allow them to be routed, or will you allow the traffic to route to Microsoft Azure. Maybe there are some cases whereby you have systems which you don't want to expose to the cloud. So you can physically say, I only want this part of my subnet to route traffic to the cloud, while the rest remains on-premise. So now, what happens is after you have created such configuration, then it is time whereby now you head to your gateway and establish the connection to Microsoft Azure. So after the gateway has been provisioned, so now the administrator must make sure that there is authentication, and the authentication must be secure in a way that you have to now supply certificates to that extent. So now Microsoft, they provide you scripts. So basically they have like templates which you can get started with to connect your on-premise devices such as your Cisco routers, your Windows remote server services, so your RRAS, so you can quickly connect your on-premise devices to your VPN gateway in the cloud. So now, after saying that, we have another option whereby now you have multi-site virtual networks. So this is where now you have multiple sites which you want all of them to communicate directly to your Microsoft Azure services. So along with cloud-to-cloud connectivity, you can also connect multiple on-premise sites to the same virtual network. So basically we have two offerings in this one. We have the standard and the high performance. So your standard, it will connect up to 10 connections. And the high performance one, it will connect up to 30 connections. So basically you will look at how big is your organization and what is the growth scale of the locations, and then you can choose the one which suits your needs best. And then it also gives the ability to network multiple branch offices through the cloud. So if you want to connect multiple branch offices together, then you can use a cloud as a central hub to connect all the spokes to the hub and allow traffic to move between the branches. So just like regional, like virtual networks, so you have to make sure that you make sure that your subnets, they don't overlap. So your network administrators will have an idea that you can't have same subnets on the same network. So then you must make sure there is no overlap. So your on-premise network shouldn't overlap with your cloud network. So now, the other part is we have to look at the point to site connection. So where I told you that it's only for proof of concept. So basically this one, it differs from the site to site by allowing an individual computer or a server to connect over your secure tunneling protocol. So instead of you connecting the whole company, now you're only giving access to one person to be able to access the resources in Azure. So now, in the security standpoint of view, the connection is secured by certificates. So the person or your developer will be interacting with Azure services. They must have an existing certificate which is trusted and which must be shared between their computer and the cloud. So as I've mentioned, that this scenario, it is very perfect for prototyping your hybrid applications without requiring upfront time investment on site-to-site network. So if you want to just get started quickly on your hybrid connections, then you can start with your point to site and see really how it can help your business to move faster to the cloud before committing yourself to a site-to-site VPN. Now, the development and test, it will be much easier to demonstrate since it doesn't have a public IP requirement like the site-to-site network. So basically, the person will be connecting to through the site-to-site connection won't need to be allocated a static public IP, so they can be anywhere they want and they can still interact with Microsoft Azure. So these are the offerings from site to site, multi-site, and point to site. Now, the other important feature here is we have to look at the DDoS protection. Now, we have seen a lot of organizations have been attacked, and we don't want you to be part of that list. So now what happens with DDoS attack is when now an attacker tries to exhaust an application's resource. So basically making that application unavailable to legitimate users. So what you can see on the image there is I have a round face there of my attacker. His traffic, it is represented by orange color. I'm not sure how you guys seeing it on your side, but it is orange. And my customers, they are having a slightly yellowish color. Now, what happens is as that traffic hits Microsoft Azure backbone, then it meets the DDoS protection service. Now, the service is intelligent enough to recognize patterns to say that, okay, this traffic, it is legitimate, and this traffic, it's not bringing any good use to the virtual network. So as you can see, towards the virtual network, we only have the customers' traffic going through. So now these DDoS attacks, they are targeting any endpoint that is publicly reachable to the internet. So if you have your front-facing web services, those are publicly seen around the internet. So DDoS, they normally attack such services. But now also Microsoft Azure has invested so much in the mitigation strategies. So now these are some of the strategies which they are implementing and going on forward. So now we have what we call the volumetric attacks. So basically, if you understand the notion of botnet, whereby they now attack with multiple machines to the same endpoint. So that goal is to flood the network layer with amount of junk traffic, which is seemingly legitimate traffic. So how is Microsoft Azure solving that one? It has a DDoS protection standard which mitigates these potential multi-gigabyte attacks by absorbing and scrubbing them with Azure's global network scale. So basically, as we know, Microsoft Azure, they have the biggest network infrastructure in the world. So they are using that platform to absorb all that traffic which was meant to hit your endpoint. So basically, as they see the pattern grows that your endpoint is experiencing much pressure, then Microsoft Azure will jump in and absorb that traffic so that it can redirect that attack to the global scale, which it will be like a dot in an ocean to them. So now, the protocol attack. Now, this is where now they are attacking the layer 3, which is your IP layer, and your layer 4, which is your TCP IP. So basically, what they're doing the flood attacks, reflection, and also they can target other protocols within those two layers. Now, how does Microsoft Azure mitigate protocol attacks? Now, how it does is it runs differentiating between malicious and legitimate traffic. So what it does is it interacts with the client. So it interacts with the client, making sure that the requests which are coming from those two layers, are they from a correct person, and is that a person or is it an automated system? Now, the final one, which is the resource. Now, this is the one commonly used by hackers, which they try to violate network, compromise network security by doing things like cross-site scripting, SQL injection. So basically, they are trying to attack the layer 7 of the stack. So now, Microsoft Azure, in that case, it allows you to deploy what we call an application gateway web application firewall. So that is a special kind of firewall which sits behind or which sits above your web servers, your front-end services. So it has that intelligent capability to detect layer 7 attacks. So it is called the application gateway web application firewall. So this firewall, it provides defense mechanism against such attacks. So now, with all that has been said, I believe Bhavin has shared this insight on where can you start in our customer side, Azure, the licensing and the CSP. So that's it from my side. I hope this was too informative to you, and back to you, Bhavin. Thank you.
Okay, I think this then brings us to an end. Does anyone have any questions?
So you must go to portal.office.com, try and log in with the username and password you created.
Okay, so then if there are no questions, then thank you very much. Or alternatively, you can pop either Bhavin or Glenn an email. Email address is on the screen. Yes?
I do have a question.
Yes.
I just want to know, is there any South African service yet?
No. So Microsoft last year announced that there'd be data centers launched in South Africa this year. We haven't heard as to when it's happening as yet. We just know it's sometime between now and the end of the year.
Okay. And tell me, as a developer, I obviously can launch a platform and to do development of a product. But my range of customers range from big to small. And obviously the bigger customers will subscribe to the service, but what about the smaller customer that don't have that much storage and traffic needs? Is there a free platform available on Azure, especially for SQL?
No, so Azure is a paid for platform, but if you actually go onto the Azure website, you actually see that Microsoft has made kind of SQL databases available at a relatively low cost, and quite simply, then your customers would be able to buy from you, and then you'd buy from us. But yeah, so Microsoft has made that relatively cheap.
Okay.
Yeah.
Yeah, it's just a very confusing website that.
Is
I
it?
mean, to get to the actual price is very, very difficult.
Yeah.
Um,
Okay, so look, let me take this as an action item. It's Vian, right?
yes.
Okay, Vian. So Babin will maybe just give you a shout after this, just to go through that.
Okay. Okay, good. Thanks.
Okay.
But you are hosting the service on behalf of them in South
So
Africa.
we don't host anything. It is all hosted with Microsoft. So all we do, we sell the service.
Okay.
Yes,
Okay.
yeah.
Sorry, your name?
Elaine.
Elaine. Okay.
Yes.
Thank you, Elaine.
Okay, thanks, Bian. Any,
Yeah, okay, bye.
thank cheers. Any other questions, anyone? Okay, yeah, look, we'll hang around for a little bit. If you do have any questions and you don't want to talk, feel free to just type it up in the chat window as well. But yeah, thank you very much, everyone, for your time. And this brings us to the end of our broadcast.